is the thermal process that takes dry solid fuels, like wood, and converts them into the most basic elements. And then as those basic elements come together, they form a gaseous fuel called syngas, or producer gas. In our case, it's called wood gas because our medium that we're using to burn is wood. And so it takes the wood, it converts it into carbon monoxide and hydrogen by reacting the raw material at high temperatures, upwards of 700 degrees, with a controlled amount of oxygen and steam. And it burns more of the wood, and even burns the creosote, because as the creosote sticks to the sides of the boiler itself, when the boiler cools down at different intervals from usage, the creosote flakes off the sides of the boiler. And when the fire starts burning again, it burns the creosote that fell off. So it's very clean as far as creosote goes, and it's more efficient than direct combustion. And of course, direct combustion is what we use in our barrel stoves, in our wood cook stove. That's all direct combustion. Here is a nice little diagram showing the process of the biomass feed, being the wood, that would come in, and of course the first thing that happens is a little bit of drying that takes place. And then we have the pyrolysis zone, the combustion, the air that's coming in to help that combustion out. Then it's reduced. All the gases are reduced. There's a grate there where all of the ash falls, and what is produced, what is the gas here that's being used is the syngas. And we're going to look at all these processes specifically so we see exactly how they're all used. Okay, the next slide here shows the gasification process simplified, using an example of what a gasification boiler would be. So the first process that happens is the wood fuel is conventionally ignited in the upper combustion chamber. And you see the arrows here that are not pointing to it. Just one moment. We're going to open up another slide. And it's going to cycle through numbers here for us, hopefully, or no. So number one's up. You see the arrows here. So this is the wood fuel that is conventionally ignited in the upper combustion chamber. And the second arrow is when the upper boiler doors close, the draft fan begins drawing up the fresh air. Number three, the fresh air is forced downwards through the logs and coals, intensifying the initial combustion. You see the fire fueling up there. Number four, additional superheated air is forced into the lower chamber, producing intense heat and nearly complete combustion. And then five, the remaining gases pass through the stack of the lower chamber up through the turbulators for final heat transfer and exhaust. And then it starts over again. The first process then is pyrolysis. And the pyrolysis is also known as the devolatilization process, and it's the thermal decomposition of biomass fuels in the absence of oxygen. So at this stage, we don't have oxygen entering the process. The pyrolysis involves the release of three kinds of products as it's burning the wood. The first product is the solid, known as charcoal. The second is the liquid, which is oil. And then the gases, such as carbon monoxide, hydrogen, nitrogen, and various others. The ratio of the products is influenced by the chemical composition of biomass fuels and the operating conditions. So depending on what your boiler is burning, the fractions of, or the ratio of these gases will be different. For instance, if I'm burning propane, I'm not going to have the same amount of carbon monoxide as I would if I'm burning wood. It depends on what you're burning. And the heating value of the gas produced during the pyrolysis process is low. It's 3.5 to 8.9 megajoules. And if you refer to these over here, you see that 3.5 megajoules is 3,317 BTUs. It's not even enough to heat my house 1 hour in the summertime at 60 degrees. And 8.9 megajoules would be 8,436 BTUs. The second gasification step is the combustion process, which occurs as the volatile products and some of the charcoal reacts with the oxygen to form carbon dioxide and carbon monoxide, which provides heat for the subsequent gasification reactions. Pyrolysis and combustion are very rapid processes. And this is a very important point when you're comparing boilers with barrel stoves. The barrel stoves also produce carbon dioxide and carbon monoxide, but they're not used for anything. It just goes right out the stovepipe into the atmosphere. Whereas with the boiler, these gases are used to actually produce more heat to help with the next process. So I have a little video here. Okay, so the next gasification step, step 3, is gasification. Gasification is the process that occurs as the char reacts with carbon dioxide and steam to produce carbon monoxide and hydrogen, which, as I said before, is called wood gas when fueled by wood. And here I have added a little diagram of how these break down. Carbon monoxide is 15 to 30%. The reason why there's a variable there is because it depends on exactly what type you're burning. Hydrogen is anywhere from 10 to 20%. Methane is 2 to 4%. Nitrogen is 45 to 60%. Water, which is really steam, is 6 to 8%. Carbon dioxide is 5 to 15%. And these are the producer gas constituents. In addition, the reversible gas phase water gas shift reaction reaches equilibrium very fast, balancing the concentrations of all of these elements. So the next question is, why would we want to choose gasification boilers over barrel stoves? So here I have a little section of the spreadsheet showing how much I pay for cords per year, which is yearly $4,070. How much that would, my stacking time, how much money that would equal, and it's $352, and that is really a conservative price. My time would be worth $352. My propane heater bill is $670 yearly, and my electric heater bill for only 5 months of the year, remember, is $579.84. That adds up to be $5,671.84. The next thing I looked at was now comparing the boiler stove and everything I have to use with it to make it a successful heating device in my house with the gasification boiler cost. According to Alternative Heating Systems, which is the company I'm using to look at boiler estimates, their boiler will break down and my cord usage a year to only a third. So when I would normally use 22 cords of fuel a year to burn in my house to keep it warm, I would only need to use 7.5 cords of wood to keep it at that same heating temperature. And remember, it's not just heating my house, but it's also giving me water, domestic water as well, and cutting out the use of electric